Good morning, good afternoon, good evening to everyone. Welcome to this session on endpoint profiling and APIs, specifically using network packet analyzers. So this is a beginner session for those who want to just try out a new tool, but it is also an available intermediate session for those who might want to take the concepts that we're going to talk about today and delve into them a little bit deeper on their own. But for today's discussion, we're going to go over a few things. First, we need to talk about profiling in general. Why is it important? And how does ISE perform profiling? Secondly, we're going to then talk about ISE APIs and how we can work with ISE using those APIs and then affect our profiling of endpoints. And then we're going to look at how we can gather data around our environments to then send to ISE via those APIs, and what kind of data that we're sending will be gathered through a packet analyzer process. And at the end of this, we're going to wrap it all up into taking all those individual components, putting them together into a nice cohesive solution that you can deploy with the use of just a few commands. But first, as Rico mentioned, I would like to learn a little bit about the people on the call today. So we're going to do a quick Slido poll. So please grab your phone and scan the QR code. And we'd like to hear from you about what tools are you using for profiling today. Now, these tools could be ISE, just that you're building custom profiles within ISE, or maybe you've integrated ISE with Catalyst Center and you're using Catalyst Center to help profile your endpoints. You can put ISE and Catalyst Center. You can put in multiple entries to this. Or maybe you've bought a third-party tool of some sort. Or maybe you're like me and you've built a third-party tool. Let us know what you are using today. And I'm going to leave this up for just a few minutes so we can see people are adding some new ideas. So looks like ISE is, of course, the main one. There's some Metagate, DMAC. Okay, no profiling at this moment. Okay, so the person who put no profiling at this moment, you might see a reason why you might want to do that going forward, because we're going to show you some benefits of what you can do when you learn more about what's in your network. Looks like Duo trusted endpoints, okay? And some people are using the specific protocols. Okay, see a few more participants typing, so we'll wait a little more. Okay. All right. So thank you all for filling that in. The next thing I wanted to ask is a quick survey on your skills of the people that are on this call today, what your understanding is of two technologies we're going to spend a lot of time talking about. So those two technologies would be Wireshark and Python. So if you want to go ahead and fill out your experience with these, now Wireshark being a packet capture analyzer, you could say maybe you've never used the tool before and that would be a 1, or you use it fairly regularly or know what it is. That's kind of maybe a 2 to 3 or 4. And then 5, if you use Wireshark all the time and you understand all the details of the capabilities within the platform, maybe give yourself a 5. So it looks like we're lots of people in the 2, 3, and 4 range. It's good. And again, you don't have to be an expert in any of these tools. This is just trying to understand who is attending the session so that we can make sure we don't cover or skip over topics that may need more detail. And while everybody's filling that out, also let's see what the Python experience is of the attendees. So lots of 1s, okay? And I should put a caveat on here. You do not have to be a Python programmer to attend this session. You don't have to understand Python at all, because Python is what this was built from, but the interaction is a single command. So don't be worried if you gave yourself a 1. And if you're a Python expert and you've spent all this time coding, go ahead and pat yourself on the back for all the time you've spent on a prompt and give yourself a 5. But do not worry if you have little to no Python experience. All right, so it looks like there's a few more participants, but I think we've got a good start. So let's start with the meat of this discussion with profiling. Why is it important? So we hear the term zero trust networks all the time, and really the zero trust network is the pinnacle of a secure network because it does not trust anything implicitly, and you can create the most granular security policies to protect your network. But to deploy such a network, you need to know as much about your endpoints as possible. The more we know about our endpoints, the more effective our security policies can be. But our identification process of those endpoints is becoming even more difficult as time goes on because IoT devices are blowing up. We have 15 billion devices today of IoT devices across the world, but that's supposed to double by 2030. We have this difficulty of identifying those devices correctly, because if we don't, we expose ourselves to exploits and malware attacks. And you can see there's plenty of customers out there who have had the terrible experience of a cyber attack because they did not properly secure their endpoints. So the most data that the more data we can extract from our endpoints, the better our profiling will be. So for instance, if we can take data that's on your network and combine it with these generic devices, what if we could learn things like the specific type of device or the model number or the operating system, maybe even serial number? That would help us turn these generic devices into more accurate profiles. Like instead of it being an Apple device, it's a MacBook Pro 16-inch with M2 processor manufactured in 2023. Or instead of it being a generic Philips device, which could be a medical device, it could be an appliance, or in this case, it actually happens to be a smart light. What if you could learn that detail about it and the model of that smart light with the OS version running on it? Or maybe if you're dealing with randomized MAC addresses in your environment, you don't know what kind of device is using that randomized MAC address. What if we could see actually the model of the device behind that randomized MAC address or the OS version running on that endpoint? That's the kind of visibility that we're looking at here. And the key thing here is that this is using your data in your network to make these better profiling decisions. But this is a completely passive tool. We are not probing your endpoints and gathering additional information from them. We're just listening to the data that your endpoints are already advertising on your network. So before we can get into the nuts and bolts of how this software works, we need to do some admin tasks to make sure that our ISE instance that we're going to integrate with is set up optimally for profiling endpoints. That way we can follow best practices and avoid misidentifications by allowing ISE to work optimally. So how does ISE do profiling? There's really two components to this. The first component is the switch configuration, or the wireless controller configuration as well. But this includes your radius configuration, so your AAA settings, or your SNMP credentials that you define, or if you're using DHCP helper IP addresses to send DHCP data, or preferably if you're using device sensor, which is a Cisco Catalyst feature and allows for us to take things like CDP, LLDP, and DHCP, take those protocols, those advertisements from endpoints, and convert them to radius accounting messages. So they get converted to radius to be sent back to ISE for further analysis. And for those who haven't seen kind of a default device sensor configuration, this is what it looks like. You can paste this into your Cat3Ks, your Cat4Ks, your Catalyst 9Ks, or even Catalyst 9300Ms are using the same capability, as well as Meraki 390 switches. So making sure that we're gathering as much information as possible from our switches helps us to identify endpoints. But the other half of the other side of the coin here is making sure that ISE probes are configured correctly to receive this data. So that would be the default probes within ISE like radius and DHCP, etc. And that the thing about probes is you want to make sure that they are consistent across your PSNs or your policy service nodes in your ISE environment. Because if your probes are not consistent, one portion of your ISE deployment might be gathering more data than the other and making better decisions, while another one only has half the data. So we need to make sure that probes are consistently defined and enabled so that you do not have inconsistency of profiling data and therefore inconsistency of policies created. So what are those probes that I'm talking about? These are the defaults. So ISE profiling probes that are enabled for various protocols, these are the default settings, and included in the defaults is the radius probe. Like I mentioned in the previous slide, this is what device sensor uses for learning additional data about your endpoints. And once that data is learned, we can make policy decisions from it. But for today's discussion, we're not going to talk about stuff built into ISE. We're talking about a third-party tool, and we're going to therefore use pxGrid, which is called Platform Exchange Grid, and is the way that we can communicate from ISE to other third-party systems. Now, pxGrid, if I turn this probe on just right now, you might get an error message that says you need to be running the pxGrid persona. Now that's fine, because essentially, if you've never turned on pxGrid, it's saying I can't analyze data on a service that's not running. So to get around this error, to fix this, all we have to do is go to our ISE deployment, and we'll look at all the individual nodes in our environment and say, okay, I want to turn on the pxGrid persona. Now there are a large number of best practice designs available for enabling the pxGrid service based on the size and scale of your ISE environment. And we'll have some links to those resources at the end of this video. But the gist of turning on pxGrid is you simply click on a node, turn on the toggle switch, and in my case, I like to enable pxGrid Cloud for future integrations. And then as soon as you turn that on with the probe in the previous slide, that turns on these IOTAsset attributes for your endpoints. So all of the endpoints in your ISE environment now have additional fields added to them for allowing third-party integrations to write data to those endpoints. So add additional context to those endpoints, which is what we will use with this software I'm going to demo for you today. Now, these fields you'll see popped up in other examples as well. So I want you to remember IOTAsset. And so whenever you see asset, that is the IOTAsset attribute fields. Now, we know with these settings enabled, we have the best practices for our configurations and our probes. We can now start talking about how are we going to send data into ISE. So we're going to use ISE APIs. Now, there are two types of APIs within ISE. First, you have your open APIs, which are your traditional REST APIs. And these are your typical request response. So this is, I'm saying, what's your name? You say Bob. I say, where are you from? You say New York. Okay? And now I've learned some information about you. They're very simple request response transactions. But there's also WebSocket APIs. Now, WebSocket APIs is where you might hear the term pxGrid publisher and subscriber. So that idea is more of a streamlined real-time monitoring of activity or real-time streaming of data. And that is essentially a handshake between a client and ISE, and a TCP connection is established between the two of them. And this is really great for sending real-time updates. So in the previous example of Bob from New York, I could say, Bob, tell me about your growing up in New York. And then Bob tells me a long story and giving me all this context and data. And I started learning more information about Bob and how he opened up a shop in New York City. And that is real-time activity. I'm receiving a stream of data from Bob. So with that understanding of the kinds of APIs, when we work with pxGrid, there's two, we're going to use both types. We start by saying, I want to do a REST API query. So I need to learn a little bit about the ISE environment first. I need to know what pxGrid server should I connect to? So I'm going to query ISE and say, which one of those nodes did you turn on that pxGrid persona for? Because maybe I have 10 nodes in my environment and it's the node A is the one that responds back as that's the one that's running pxGrid. And now that I learned that information, I can say, okay, what services are available on node A? And in this case, I would get a response back saying service A or service 1, service 2, etc. are available. Once I have learned that information, I can then say, I want to establish a WebSocket connection, aka use the publisher and subscriber APIs. Now with these, what I'm going to do is I'm going to say to ISE, I would like to publish service 1 on node A. And again, ISE would have to approve the request, but then once that established connection or that WebSocket connection is established, I can now either send data directly in if I'm publishing into ISE. So I can say I have an update for this endpoint, I have an update for this endpoint, and ISE will receive that data and automatically populate its database with my new context. Or vice versa, I can subscribe to receive data out from ISE. In our case, we're going to be doing a publish of data, in this specifically publishing endpoint context. So even at this point, this might sound a little overwhelming of all the different components and processes that have to happen. But the nice thing is there are tools that have already been built to help you work with ISE a lot more easily. One of those is this tool called pxGrid util. Now, pxGrid util is a Python library that was written by one of our engineers, and it takes all of those settings of those API calls to ISE and automates them into a single command. So in this case, this would be a single RESTful request to ISE. So I would say, I would like to know all of the sessions that are currently in the active state or started state, and I'd like to know their MAC addresses. So this would be a single request and response. In this case, I provide the host name of my ISE environment. I provide a node name, which is essentially my username for the credentials I'm going to provide, a node secret, which was my password for that credential. And then in this case, I did insecure, which is just saying I don't need to verify the certificate that's in use in ISE because I trust my environment. I know what this is. And the response back that I get are the MAC addresses. And that works well for just a stateful request. But maybe I want to do a WebSocket type request where it's a streaming of data. Well, for that, I have something like pxpublish. A pxpublish is, again, a single command, but I provide the credentials of the name of my ISE instance, my username, my certificate details. So -C, -K, -S are my private cert, my private key, and the root CA certificate of my ISE environment. That allows me to do a certificate-based authentication, which are enable you to scale these kind of integrations a lot greater because pxGrid certificate-based authentications, as far as I believe it was 3.2, introduced a lot more scalability, or sorry, 3.1 introduced more scalability using certificate-based authentications. Now, I also really love the ability to define services and topics, as well as these are the specific services I'm going to subscribe to and the topic within that. So in our case, we'll use the service of endpoint_asset, and the topic is we're going to add IOTAsset attributes to this endpoint, and I could even include a additional value of verbose, and that verbose argument allows me to see everything that actually happens on the back end. So I can learn more about how this process is actually working by using that verbose command. And this tool is really going to be our starting point. We're going to use this and just expand upon it and add endpoint visibility from our software here. So to do this, we're going to use certificate-based authentication. So again, certificates, most people recoil in horror when you talk about certificates, but trust me, this is easy. I was a customer Before coming to Cisco, I was a customer for over 10 years using ISE, and certificates always seemed very difficult, but we have made great advances in how ISE handles certificates. And this is a perfect example of how easy it can be. In this case, I would go into my pxGrid configuration, provide a username and password for my certificate. And once I export that certificate, I get two files. I get my private certificate and my private key. But then I needed a third file, that root CA, for my system certificate. Now, in this case, the administration system certificates and node, I would be able to see, in this case, the pxGrid service is running on, in my case, an ISE 33 node. And that node, I will export that certificate, and I now have 3 files. So those 3 files are all I need to do to work with this Python script I'm going to show you. But the other optional setting that you can do is turn on automatically approves new certificate-based accounts. Now, this is essentially a way to streamline the process, because as it exists today, if you were to authenticate with these new certificates that you just exported, you would then have to log into the GUI, approve that new request, because yes, you authenticated, but you were not authorized to do anything until I am approved. So then you can turn on this additional setting, and that helps streamline the process. So again, this looks like a lot of text and a lot of complication, but I want to show you a quick video of how easy this can be. So this is an ISE 3.3 instance, but the process would be the same for any other ISE 3.1 or above. But I would go into pxGrid Services, Client Management. Once I click on this, I then would go into my certificates and say, I want to generate a new certificate. So that could be without a certificate signing request, because this is a brand new request. And I'm going to give it a username, pxGrid test. And then just say, I want to export this as a PIM file, and I will then provide a password to encrypt it. Once I hit create, this is going to generate a zip file with all the certificate files that I need. So if I open up that file, I'll need to extract the certificates within the zip file. So inside of it, there's several certificates, but what I really care about are these two, my certificate and my key. So I'm going to move those to my home directory just to make it simple. So I have just those 2 files. And I now need to go back into ISE, and I'm going to go to my system certificates. Just hit OK to get out of this window. And you can see under my system certificates window here, I have the pxGrid service is using the default self-signed certificate. Now, this will be different in your environment depending on how you have it set up. But in this case, I'm going to export that certificate in just the certificate. I don't need to export the private key. Once I export that, I now have that third file. So in this case, I'm going to just drag that into my home directory. And now I have the 3 files that I need. That took a minute and a half. It's very easy. If you need to go back and rewatch this video again, that's how easy it is. So we now have our certificates. We now understand how we can use those certificates to work with ISE APIs. Let's go gather some data. So we need to get more information from our endpoints for profiling. And what do I mean by that? So ISE profiling, as I mentioned before, uses device sensor for radius communications. And that would include things for your endpoints that are advertising DHCP or LLDP or CDP data, etc. That gets to a switch, and the switch sends that information to ISE via radius updates. But our endpoints are using a lot more protocols than just those. They're using multicast DNS, or they're using SSDP advertisements, or if it's a phone, it's using SIP, or IoT devices use universal plug and play advertisements that send out a lot of information about themselves. And those protocols would be really great to use for profiling, but they hit layer 2 or layer 3 boundaries before they can actually get to ISE. So all that data is lost. We don't have the ability to see that information in ISE. So what if we could find a way to get beyond those layer 2 and layer 3 boundaries? And how we can do that is we would deploy collectors. So these collectors, in this case, we could deploy across our environment. So I have a ISE environment may be sitting in a data center, and I need to gain information from my various distribution grids or my various access switches. I could deploy these collectors wherever I needed to, so they could be either directly attached to a switch and do a span, or they could be remotely deployed to a maybe another data center somewhere or some other centralized point, and it could do an encapsulated remote span or ER span. And I would send copies of my network traffic to that collector, and then that collector would then analyze the data, and using those APIs and those certificates that we just talked about, they would send information to ISE via pxGrid updates. Hey, ISE, I learned about a new endpoint. Let me tell you about it. And over and over and over again. So that's how we get around those, getting those protocols all the way to their destination in ISE. So hopefully this is making sense, because now we're going to talk about the meat of today's discussion, which is network packet analyzers. So you saw from the earlier slide, a lot of you are familiar with Wireshark. You've probably used it troubleshooting issues or just for curiosity of seeing what's out there on your network, but it's a great tool for packet inspection. And most of you have probably used the GUI version of this, but there's also a CLI version of it called tshark. Now, somebody spent a lot of time and took that CLI-based version of tshark and built a Python library around it. So essentially, they took Wireshark, built it in Python, and now they have a thing called pyshark. So whenever you see this little icon, excuse me, that is what I'm going to use to refer to pyshark. But essentially, this allows you to work with Wireshark in a Python terminal. And you can easily install it using pip, which is a Python package manager. So if you want to learn, or if you want to install additional Python libraries or additional software in Python, you can use pip. And in this case, you just type in the command pip install pyshark, and that installs this library for you. Now, there's other packet analyzer tools out there like Scapy or DPKT, and they have different benefits and cons to each one of them. But in my case, I like pyshark because I'm familiar with Wireshark, and pyshark is a very good representation of Wireshark. So my familiarity was the reason why I chose this for this tool. But let me show you what pyshark actually looks like. In this case, on the right-hand side, this is a Python terminal. So this Python terminal, if you are working in a workstation and you just type in the word Python, or you double-click on the Python exe if you're a Windows user, you will see a terminal window like this. And that terminal window, the first thing that we could do to work with pyshark is we want to import that pyshark library that we just installed. Once we import that pyshark library, I can start adding functions based off of what that library allows me to do. In this case, I can load an existing wire capture called, in this case, span_capture.png. I can add that to this Python instance, and then I can choose to print the first package or packet. In this case, it would be the same thing as clicking on that first packet within a Wireshark view. What would I see? I would see the Ethernet layer and the IP layer and the TCP layer and the HTTP layer. I would see all the additional OSI layers of that endpoint displayed to me in a nice, consistent format. And that's what you get with pyshark. Now, this is a basic view of this, but let's do some examples of working with pyshark. So maybe I don't want to load a static capture. I want to instead run a live capture. Well, you can do that with the commands listed above, where you can see I type in live capture on my interface name. In this case, this is EM0, which is just my local Ethernet port. And I could choose to run it for 10 seconds. I could choose to run it for an hour. Once that capture finishes, I can see, okay, I captured 6,000 packets. That's cool. Maybe I want to see what's in the 15th packet of this capture. What kind of packet is that? Oh, it happens to be a MDNS advertisement. Okay, that's cool. I'll take that capture packet and I'll assign it to a variable called packet. What's in that packet? In this case, I want to see what layers of the OSI model are in that packet. In this case, it has an Ethernet layer, an IP layer, a UDP layer, and an MDNS layer. I now know, okay, inside that Ethernet layer, tell me more about this. So I'm going to say in the Ethernet layer, tell me the source MAC address. In this case, that would be the endpoint who transmitted this packet. So in this case, I've now learned the MAC address of the endpoint. And that is where I can now correlate that endpoint MAC to a MAC address that lives in my ISE environment. So I can start saying, okay, anything else that happens from this endpoint, I can now add as additional asset values if there's something important. In this case, let's look at an example of where a higher level OSI or like a layer 7 packet, I could see a HTTP advertisement. In this case, this was a smart TV that advertised out a user agent string. Now, typically, ISE can process user agent strings when you send a web authentication for an endpoint, but this is an IoT device. He doesn't have a way of authenticating as a guest endpoint in ISE. So I would never see this user agent string, but I have that value available to me to store as a variable in ISE that I can then refer to later on. I even have additional data in here, including like universal resource indicator, or in this case, a URI value, which allows me to query that endpoint for additional data. And again, this is passive. You could build a program that would query this IoT endpoint to gather more information about it. But this tool that I'm showcasing today does not do that. It just listens to the conversation. And if you want to take the intermediate route of today's discussion, you can also use PyShark and learn more things available for each layer or different fields within it by using things like field names or all names when working within Python to learn more information and how I can extract more data from these packet analyzers. So again, I know that a lot of people are on the one scale of Python. That's fine. You don't have to understand all the details of this, but I wanted to explain it a little bit more. But let me put it all together for you. I'm going to make it a nice cohesive package for you as you can understand all the things that we've talked about before. Let's see it in practice. So in this case, take an IoT endpoint, that smart Philips lighting device. Maybe I've configured it with a static IP address. So the only information that ISE has about it is the MAC address of the endpoint, which in this case, ISE would look up and say, okay, that's a Philips MAC OUI, so therefore that's what I know about it. But that IoT endpoint also sends a universal plug and play advertisement. And in this case, ISE doesn't have to respond. ISE just has to listen, and somebody else in the environment could respond to that UPnP advertisement, and that endpoint will say, hey, here's my XML. And that entire conversation, we can send or we can analyze for additional information, including, you can see in here, the model number, the model name, and additional details about this endpoint that are extracted from that XML data. So had that data been sent to ISE, I would learn a lot more about it. So in our case, if we send it to a span, to a collector, and that collector is running pxGrid PyShark, we can now extract those fields into those IOTAsset fields that we talked about at the start. So those IOTAsset fields now can have additional context, and that collector can say, hey, ISE, I have an update for you. Here's a pxGrid API call that I say, hey, here's some additional context for that endpoint. Another example of this kind of scenario is a Mac or an Apple device. In this case, the MacBook that's connected here is only known, again, by a generic device because maybe it doesn't do DHCP for whatever reason, or the DHCP is not configured correctly. That MacBook is still sending a multicast DNS advertisement. And that multicast DNS advertisement includes its model number, its OS X version, even its color. And I could take that information, extract or send a copy of it to an analyzer, and then extract relevant data from it. So I learned that, okay, the model equals MacBook Pro 16.1. This software will automatically do a lookup of that model number and tell you, hey, that's actually a MacBook Pro 16-inch from 2019. And the OS X version equals 21 on the right-hand side actually translates to macOS Monterey. So I know the OS version and specific model details of that endpoint without ever actually probing the endpoint. It was freely advertising this data. I'm just analyzing it and then sending a pxGrid update to ISE to give that additional context. So that's how you can make much more granular decisions about your endpoints because you use the data they're already advertising in your policy decisions. So let's create let's create a new profile based off of that data. So that IoT endpoint, we learned the product ID was Philips Hue. So I've got this data now in my context visibility for that endpoint. I could then go into my profiling settings and say, I want to create a new profile called Philips Smart Lighting. And Philips Smart Lighting is using a condition down here that says, if the IOTAsset field of asset protocol ID contains Philips Hue, that's smart lighting versus maybe Philips Medical, which would be the CT scanners or whatever you're in your environment. So I can make that a distinction now because I have more context. And I can then use this new profile in a endpoint policy that says, hey, if it's a Philips device, a Philips smart lighting, I want you to go into the IoT VLAN. But if you're just a generic device, you get deny access because I need to know more about you first. Or you can choose what to do with your policies. But this is where that granularity helps with better security. So let me show you a quick demo of what this actually looks like in practice. So I have an ISE 3.3 instance here. And again, ISE 3.3 is adding some additional features, including these things called multi-factor classifications, or MFCs. And these MFCs allow us to do mappings to manufacturer details, model details, device type, and OS. Now, those fields can be populated by various feeds. Now, they can be populated by our AI/ML engines. They can be populated by statically defined by the user, or in this case, they can also be written based off of what data already exists in the IOTAsset fields, which is what's going to happen in our case, because this is a brand new ISE instance with 0 endpoints. So what you'll see in this demo is on the left-hand side, when we scroll to seeing our endpoints, you'll see what ISE classified the endpoint as, but then you'll see those 4 MFC fields populated with data that we have now sent to IOTAsset fields and then have been mapped to those MFC attributes. So as I mentioned, there's 0 endpoints in this environment. So I'm going to go to my endpoints tab just to verify. And you can see 0 endpoints, refresh the screen, nothing's here. So I'm going to now go into my terminal window. And in this case, I've already installed pxRGrid PyShark, but I'm going to verify first, do I have those 3 certificate files that we talked about earlier? And yes, I do. So now I'm going to run the pxGrid PyShark command. And again, this is going to have multiple arguments in it, including a few things. First, the host name, ISE33.cisco.local, my username for my pxGrid user, and the 3 certificate files that I need to communicate with ISE. I also am adding the interface EN0 because that's my Ethernet port that I'm going to listen in on. And I'm going to add the verbose command so I can see exactly what happens as it happens. Now, in this case, I'm going to be asked for a PIM passphrase. That's that encrypted password that I added to that certificate. Once I add that, you can see all the information. It starts identifying endpoints, recording them, and updating them to ISE. If I refresh the screen, in a matter of seconds, I've already got over 50 endpoints in ISE from my span. Now, if I scroll over here on the right-hand side, you can see the value. So again, on the left-hand side is what ISE knows these endpoints as. But I could tell you that what was an Apple device, I know is an Apple TV 4K 2nd generation. Or I can tell you the difference between the brother printer models. So there's a monochrome all-in-one printer versus a monochrome laser multifunction printer. Those are different types of devices. Or in this case, randomized MAC addresses. I could tell you that was an iPhone 14 Pro Max that sent that randomized MAC address, and it's an unknown endpoint to ISE. So this is where that additional value comes in, is that we're adding additional context to ISE using those APIs by using data that the endpoints are already advertising. So that's the value here. Now, if you're like me, you're probably asking yourself, if you're a Star Wars geek, how do I learn this power? And the good news is, unlike Anakin, you don't have to go to the dark side to learn this. You just have to go to GitHub. It's available today. You can install this as a prepackaged Python library by just issuing the pip install pxGrid pyshark command. And all you need to run this is you need to be running at least ISE 3.1. So this is your encouragement to move to the latest version of ISE, because 3.1 is good. But if you saw 3.3 automatically mapped those MFC attributes to those IoT values that we are going to populate. So I could see it in my context visibility right at the start. So 3.3 allows you to see a lot more data immediately. But you need to have Python running at least 3.8. You need to have the necessary ports for those API communications to work between your collector and ISE. And you need to just send a copy of span or ERSPAN traffic to that collector for analysis. So now, the caveats. This is a concept only. So don't deploy this in your production environment and expect to be able to call TAC. This is not a TAC-supported integration. The other thing to consider with this is that if you have an existing pxGrid integration, this tool, as it is today, is writing to those same pxGrid attributes that other integrations will write to as well. So if I write values with this integration, and then I have an integration with a third-party system that's also writing to those same fields, we override the same fields over and over and over, and you end up having inconsistencies in what data is actually there for you to make policy decisions on. So keep that in mind. But the positives is that this does a lot of additional value to customers who don't have those existing pxGrid integrations, or they want to learn just more about the data, their endpoints they're sending. So you can do HTTP, XML, MDNS, all these other protocols. And randomized MAC address detection is a huge problem in a lot of environments. So I've deployed this in an environment where there was a IoT pre-shared key network. And that pre-shared key network had all these random IoT devices that were connecting and sending that data back to ISE with just a MAC address. But now I have the ability to tell you what actual endpoints are sending or are connected to that pre-shared key environment by looking at other data they're already communicating with. And again, you can do dynamic vendor model and OS lookups with this. And then maybe you don't want to integrate this with ISE. Maybe you want to just do a packet capture and see what kind of data I can extract from that. Well, if you do a PCAP file, you can do an individual file analysis of this. So and the entire process is pretty easy to set up. So let's see what it's like to actually deploy this on a collector. Like, let's build a collector right now, and I'll show you how easy it is. So in this case, I have an Ubuntu 22 VM. Now, you can download this software for free, spin it on a small VM. In this case, this is 2 virtual CPUs at 8 gigs of RAM. So it's not a very big machine. But the first thing that I need to do is issue 4 commands. I need to first issue an apt-get update to just get the latest libraries. I then need to install Python, and then I need to install tshark, and then I finally need to install my pxGrid pyshark command. And those commands are available on the GitHub for you to just copy paste. But in this case, I've got those. I'm going to pause the video here real quick. So I have those commands to just finish the installation of the required software, and that's it. But now this VM, I need to add an additional interface to act as my span port. So the port that will receive all the copied traffic. In this case, I'm going to use an RSPAN, which is just a VLAN mapping. So I'm going to go into the VM settings, and I'm going to add a new network adapter. In this case, I'm going to go to my ISE VLAN. And that ISE VLAN, once I hit save, if I do a, oops, sorry. What's that there? So if I do an ifconfig again, you can now see there's the ENS192 is the new interface that was just added. So ENS192 is the interface that I'm going to run my software against. So in the demo, you saw me use EN0. In this case, I'm just going to use ENS192. So now that I have that information, you can see on the desktop in the background, I have these 3 files. So I'm going to change my directory, and I'm going to go, oops, I should not have advanced. So I'm going to go to my desktop directory, and if I type in ls-l, I'll see those 3 files. So those are the 3 files I'm now going to use to run my PyShark service. So in this case, because I'm running on an Ubuntu machine, I need to do a sudo. I'm going to do pxGrid PyShark, provide the host name of my ISE instance, provide the username, which is ISE PyShark, and I'm going to provide 3 certificate files that I need. So that's my private certificate, my private key, and the root CA certificate of my ISE environment. In this case, I'm also going to add that encrypted password for my certificate, so I don't have to be prompted like you saw in the demo video. And then I'm going to say, what interface do I want to listen in on? I want to listen in on ENS192. Once I have that information, I'm going to also add the verbose command so I can see exactly what happens as it happens. So when I do this, let's play now, you'll see this automatically starts communicating to ISE. It created an endpoint database local, and you can see I identified an endpoint that had multicast DNS data, and then I sent that update to ISE. So I immediately, within a few seconds of this running, I now have more context about one endpoint in my environment. And this was a small lab environment of just one update, but you can do hundreds or thousands of endpoint updates in a matter of seconds, depending on how you deploy your spans. So that's how the software works. But I also want to show you a way that you can just test this out without any integrations to ISE. So say I want to use an existing packet capture and just learn what's the potential of what's in this packet capture. So in this case, you can see on my desktop, I have this test pcap.png. And I'm going to do a quick check, make sure, yep, I have pxGrid PyShark installed already. So all I have to do now is issue a command that says, well, first I need to go into my desktop directory. And now if I do an ls, you can see I'm in the same directory as that pcap file. You don't have to be in the same directory to run this next script, but it is easier. So in this case, I do pxgrid-pyshark-file, and when I hit enter, this will ask me, what packet capture file do you want to parse? In this case, I want to test pcap.pcap.ng. When I hit enter, it asks me what kind of Wireshark filter do you want to use. If you just hit enter, it uses the built-in one, but you could change it as needed. But now I can see from this packet capture, it analyzed SMB data, MDNS data, and it learned a few things. It learned the host name of my HP printer. It learned the model of my HP printer. It learned an iPhone that was using a randomized MAC address, its host name, and its model number details. And it learned a few other things about endpoints on my network. And notice at the very bottom of this, the number of local records that it just created, how many of them did it send to ISE? 0, because we did not integrate this with ISE. So this is a way that you could test out what kind of data is out there and could I use this in ISE policies? So install the software and run a PCAP file against it to learn more about what's on your data. Now, for a few recommendations to use this, please use device sensor if you're running Catalyst switches. That's a great feature that we've built into the iOS platform and use that for CDP, LLDP, DHCP. Like I said earlier, test with a PCAP file as well. But if you're going to do live span captures, make sure if you're using encapsulated remote span that you use ACLs to limit what kind of traffic you are sending in those extended remote spans, because you don't want to send a bunch of encapsulated traffic like encrypted 443 traffic or encrypted video traffic that this tool does not understand that protocol. It's not going to act like a firewall and decrypt all your encrypted traffic. In this case, you can use an example, like you can see on the right-hand side, of an ACL you could apply to that ERSPAN to make sure you only send the relevant data that this tool can actually analyze. And again, as I mentioned earlier, your pxGrid node deployment design, you need to consider what performance and scale requirements your environment might have to make sure that you enable pxGrid on the appropriate nodes. And then finally, please make sure if you're going to use this that you use certificate-based authentication, because it allows for greater scale and easier management if you have multiple collectors. So you can deploy up to 200 collectors using this software. So take 200 collectors times hundreds of endpoints on each collector. You have tens of thousands of endpoints that you could potentially learn more about. Again, this is not a production integration to ISE. So if you were to do that, that is your responsibility to maintain. TAC will not support this, but it's something that you can test for your own environments. And I encourage you to see what you like, see what you don't like, and give us some feedback on what you like about it. This is a quick reference slide for some additional resources involved in today's discussion. But in the last few minutes, I want to make sure we take care of some housekeeping items. So I'd like to ask you to please fill up the ICE webinar survey. Let us know what you thought of this. Did you like it? Do you not like it? Do you want to see it in ICE? And if you do, reach out to your account managers. Have them contact the ICE BU and say what things you liked about this, what you want out of ICE profiling in ICE. And another thing I would encourage you to do is please make sure that you use all the resources that we have available in the Cisco community spaces. So there's tons of links available for tools and guides on how you can work with ICE, and things like this YouTube series is really great for learning more about hands-on ways of working with ICE and real-world experiences. And I'd also encourage you to, if you're interested in trying out some of the newest features, sign up for the Cisco ICE beta for 3.4. This is open to anyone. So if you are interested in testing out new ICE 3.4 features, this is a pretty exciting opportunity for you. And one other thing to point out is that you saw the benefits of moving to the newer ICE 3.3 instances with those MFC attributes, but also make sure that if you are running an ICE 2.x, this is your opportunity to move to ICE 3.x. We have some ongoing migration offers available for customers to upgrade to your latest versions and benefit from all the advancements that we've added into ICE. And finally, we have an announcement for, in order to meet EU regulations, we improved the efficiency of ICE appliance power supply units. So anything manufactured after May, you have the option of buying the newer newer PSUs. So this is also just a quick announcement for that feature. We have just under 5 minutes left, but I will open it up for any additional questions. Thank you.
Excellent. Thank you so much, Taylor, for that presentation. So I just looked at our Q&A panel, and I do see that our panelists did a fantastic job in addressing the inquiries. I just see two outstanding questions here that we can address with our remaining time here. The first question is, why not have the public key of the server part of export?
So
Hopefully that
why
makes
not?
sense.
Okay, yeah. So there are two ways of doing the public root CA certificate export from pxGrid. Um, Depending on ICE environments, they can be customized in certain ways. So you need to make sure that when you export your certificates, the safer way is the way that I showed in the demo. But yes, if you have your root CA certificate involved in the signing request, you could actually export all three files that you needed from that zip file that we received. I just showed it in my demo to make it a little bit clearer of this is the exact file that you need, because sometimes all of the certificates generated in that certificate request can get kind of confusing.
Perfect. Thank you so much, Taylor. And for our final question here, is there a recommended hard drive storage size for PyShark machine, considering it will be collecting captures that will be taking up hard drive space?
So if you're saving packet captures locally on that box, there's if you're saving the PCAP files to analyze the files themselves, then that's going to be up to the user how much space you want to allocate to hold your PCAP files. However, if you're running this as a collector, the the actual capture is very, very small because it just rewrites the same file over and over. So in this case, all of my VM testing, I had a 40 gig hard drive just because that's my generic but size, but you can do far less than that because again, the packet capture file is just being rewritten over and over. It doesn't save the packet capture as part of the program.